Hello, everybody. Can you hear me? Is everything okay? Technically, okay. Well done. We'd like to thank everyone for joining us today. We hope this event finds you well and in good health. We'd like to thank Julian and Robbie, who are behind the scenes helping us make this happen today. To let everyone know how we're going to organize this, we'll have a presentation by our three experts, followed by a Q&A. So as we go on, please feel free to post your questions in the chat so we can answer them. We'll do our best to answer all of them. So let's get started. Today's subject is carbon reduction on infrastructure projects, design, construction, and O&M, the delivery partner's role. Engineering and construction has a role to play in supporting the decision makers. And to tell us more about that, we have three experts from the field, all of which who have vast international experience. To start, we have Dr. Kim Yates from Mott MacDonald. Kim has a doctorate degree in atmospheric chemistry and 25 years of international experience. She has a proven track record in the development and implementation of international best practice and is an experienced team leader and project director for complex projects. She recently developed and implemented Mott MacDonald's Global Carbon Neutral Strategy and Action Plan to become carbon neutral in 2020 and achieve ISO 14064 and PAS 2060 certification. Additionally, Kim works with the client to help deliver net zero ambition. Kim is a keen scuba diver, and do not be deceived, she loves diving with sharks. Following Kim, we'll hear from Yann LE GALLIC from Setec. Yann has 25 years of experience, where he started his career in research and development, working in the French Southern and Antarctica territories. This is where he quickly became aware of global warming. For the past 15 years, Yann has worked on transport infrastructure projects with Setec. He specialized in environmental and social impact assessments and other environmental authorization. One of his key skills is assessing global warming potential for transport infrastructure. Yann has been involved in carbon footprint assessment for projects such as the Rhine-Rhone high-speed line and currently the Seine North European Canal. He enjoys hiking and ski touring in the high mountains and hopes that the climate will allow his children to do the same. And finally, last but not least, we have Ryan Rafferty from Dragados. Ryan spent 6 years working as an environmental consultant in the Republic of Ireland, providing soil and groundwater remediation services to Irish Rail. He also spent 4 years in Qatar, consulting and managing environmental and sustainability management systems on infrastructure projects. Now in Canada, he oversees environmental and sustainability management on major projects, including the Réseau Express Métropolitain LRT in Montreal, the Confederation Line LRT in Ottawa, and the Eglinton, Crosstown, and Finch West LRT projects in Toronto. Ryan enjoys taking his daughters to parks and wetlands where they identify wildlife, allowing Ryan to teach his children the importance of conservation. So, for anyone who's just joined us and maybe missed the beginning, we're going to have a Q&A after this, so please post your questions in the chat. And let's get started, and I'll hand this over to Dr. Kim Yates.
Thank you very much for that introduction, Carole. Very good. So I'm going to talk to you about setting the scene for carbon reduction. So certainly in the UK, we have the legislation that says that we must become net zero as a country by 2050 to restrict that temperature change to 1.5 degrees C. And we also know that although the grid is greening and our operational carbon is starting to come down, that overall our carbon emissions from construction projects is going up. So certainly we as delivery partners, we all have a role to play in as part of this. Now, when we're thinking about this side of things, we need to think about the carbon reduction, but also look at what we're doing within infrastructure in terms of systems of systems. And everything that we're doing can have an effect on the economic, social and natural infrastructure and the environment. And so it's key for us as designers, engineers to think in the round, particularly when we're looking at transportation projects. It's about having a transportation solution rather than moving down our different silos, concentrating on what's going on. So again, working as an interlinked delivery partner, this is incredibly important from that perspective. So moving on in terms of infrastructure, as I said, as we're moving, as the UK, the emissions from infrastructure are continuing to go up. So again, we have a role to do that. And when you look at the infrastructure project life cycle, you'll find that you have the greatest opportunity to influence right at the beginning. So in an ideal solution, we would be building nothing. However, that's not always possible, because again, you're looking at it in the round and you're looking for those sustainable solutions, again, particularly within transport. But as you move down the project life cycle, those opportunities for carbon reduction get harder and harder to implement. So certainly thinking as a cohesive team, working with early contractor involvement, etc., when we're designing an infrastructure project is key to make sure that we realise those innovations and those low carbon outcomes. But again, looking at it in the round as we pursue, because sometimes when you're concentrating on one thing, you can end up with a perverse outcome. So again, it's a matter of doing that balancing act. And you'll find, as I said, as you're moving down the project life cycle, it gets harder and harder to implement that low carbon thinking, that new way of doing things to achieve that net zero carbon. And we really are having to think in the round when we're looking at these kind of projects. So as I said, design, construction, when it moves on to the constructor, it's all about trying to build more efficiently and do things as efficiently as possible to get those low carbon outcomes. But my colleagues are going to be discussing that in much more detail and tell you how you can do this in real life. And again, it's all about the delivery partners working hand in hand together to make sure that we hit those low carbon outcomes. So I will pass on to my colleague Yann, who's going to tell you more about the detail.
Thank you, Kim. Well, yes, hello everybody. I'm going to talk about the design phase. Once a project is decided, well, you've got basically in the design, you've got mainly three objectives for a carbon design, according to the lesson learned for the 10 years now. You got first saving lime, concrete, and steel. And second, you've got saving material to transport. And third, you've got as an objective saving natural lands. So because the most important source of greenhouse gases are earthworks with mass haul and use of lime. And you've got also structures with massive use of concrete and steel. As you can see on this picture, taken from high-speed line Toulouse-Bordeaux. This picture gives is well done because it gives the specific part of every action for greenhouse gases perspective. So you've got in brown earthworks and in green and red all the CO2 emission from structures. So, well, with these two objectives, how can we achieve these three objectives? Setec is used to study different ways in the design. So if we start with the first objective, saving concrete, steel, we've got mostly four ways in terms of design. The first way is to reduce the size of structures, if possible. We're talking about viaducts, tunnels, cat and covers, green tunnels, etc. But to the extent that other environmental objectives are met, because this is the issue. We also have to protect flooding areas, landscape for local residents, ecological corridor, etc., etc. So reducing the structures, the size of the structures is one objective, one way, but you've got also other constraints to respect. The second way is improving the design of the structures themselves, of course, while respecting technical standards and performance objective over time. The third way is about drainage system. So designing a drainage system that require less concrete as possible. Again, while respecting technical standards and water protection objectives. And I would say the fourth main way is about track. I think favoring ballast track over slab track is an issue. Even though there are many other constraints to consider, but in terms of carbon cost, this is an issue to take into account. So let's carry on the second objective, lowering material transport. To reduce the mass haul, there are two main ways that quite obvious. Most of the designer knows that. The first one is to find the best balance between cuts and fills, thanks to a profile as close as possible to natural ground. However, this leads also very often to a large proportion of treatment with lime, which reduces the gain, as lime itself produces a lot of CO2 for its production. So there is an important issue about that, because at the end of the day, this is what we can say from the lesson learned. For an optimized project, lime is very often the main cause of CO2 emission, as I showed you on the before. So as well, the second way, quite obvious as well, is looking for borrow pits for external materials and deposit for unsuitable materials as close as possible from the track. You can see on the picture there that taken from Canal du Nord in the 1950s. The deposit were at that time put just near from the track, which is a good way of avoiding extra mass haul. Let's talking about the third objective, lowering land use. As vegetation and soil play an important role in carbon storage, switching them to artificial grounds contributes also to CO2 emissions for quite a high level, actually. So in the design, we've got to avoid forest and grassland because they are land uses that give the strongest carbon storage over time. And as well, we got to look for a sober geometric design to use as few land as possible. This goes generally hand in hand with a good balanced profile. And this can also concern equipment such as side roads for service access. So at the end of the day, all these objectives can sound quite simple, actually, but mixing them all together and achieving a low carbon design can be quite complicated at the end of the day, because all these, there are many parameters to consider. Some of them going potentially to the opposite way of the others. For example, if you think about treatment with lime, would you choose treatment with lime or using extra material from bore pits? This is a question that a designer can have in terms of low carbon design. So only iterative comparison with the use of models of different solutions can provide a balance between gains and losses for the main choices. For example, when it's about lowering the profile to hide the root, is it at which extent it is acceptable in terms of CO2? This can be a question, and to answer that, it's you have to make calculation and modeling. And so that's why Setec has implemented a model specialized for a liner project and use it for different projects. For example, Canal du Nord, for example. Well, so this is also as well. There is the choice of carbon efficient material is an issue. This can be pushed in the procurement. So I have to mention that Setec has also its own lab for material, which is called LERM, L-E-R-M. And it has to be, it has been, LERM has been involved in the reuse of material on the high-speed line Lyon-Turin, for example. Thank you for your attention.
So as Yann said, there's an awful lot that we can be doing working together from this perspective in terms of looking at new materials, etc. But it's becoming easier and easier to look at the carbon at the design phase by interlinking it with BIM models. And you can see here, again, you can make those low carbon decisions right at the beginning. And interlinking it with BIM means that you can do those hot spotting, and the designers and the engineers can be looking for that low-hanging fruit in terms of carbon from a carbon perspective. So I think we all have our various tools within MOTS, for example. We use the Moata Carbon Portal that again allows you to make those quick and easy decisions. But as they say, there's lots of tools out there, but there is no replacement for good designers and good engineering and working collectively as a team. So I'll pass across to my colleague, Ryan.
Thanks, Kim and Yann. Thanks for having me on this great discussion. Dragados certainly appreciates the opportunity to share some of the strategies and lessons that we've learned on reducing carbon on our transit projects during construction, and happy to compare notes with international experts. A lot of strategies and opportunities are available to reduce carbon emissions during the construction stage, which can also complement and planning and implementation for long-term carbon reduction strategies during the operational and maintenance stages. Some of those strategies are presented on this diagram. Typical for construction projects, we'll have procurement and waste management processes to optimize material usage, to ensure resilience and durability, and minimize waste, including embodied carbon. For example, the selection of low carbon materials and concrete. We'll also have traffic management plans in place to avoid congestion and increased emissions, as well as keep pedestrian and cyclist routes open and safe for use. We will also establish protection zones around adjacent carbon sinks, such as trees and topsoil, to avoid damage or impairment. In fact, utilization of existing vegetation for erosion and sediment control can help protect existing carbon sinks, as well as reduce costs for things like silt fencing and soil blankets. In cases where trees need to be removed from the project footprint, typically these are replaced at ratios of anywhere between 1:1 and 8:1, which is an excellent opportunity to significantly offset carbon emissions for a project. Soil movement has also a major carbon footprint, as Yann was mentioning. This is why we established procedures for optimizing the reuse of excavated soil along the project alignment, or arranging soil relocation agreements with other projects such as backfill for bridges, roadways, and building construction. This cuts down on cost as well as carbon emissions. Heavy machinery is also a factor. Here we use best practices to minimize emissions from construction vehicles and equipment as much as possible, such as having no idling policies on site, having regular maintenance schedules to reduce fuel consumption, and the use of low carbon technologies where available in the market. The next slide will show one approach for identifying opportunities to reduce embodied carbon on certain materials that we would typically encounter during a demolition stage of a project or to be used during construction. Diagram shows some of the more intense carbon intensive materials that we would encounter on a project through demolition or construction. Carbon reduction during construction really needs to start at the beginning when planning and procurement waste management strategies are being planned. Materials with high embodied carbon can be identified early on in a project, both during a detailed waste survey prior to demolition and during procurement planning, so that materials can be recycled, reused, disposed of with optimal carbon savings. Waste management is always a priority in all projects and is also an opportunity for planning to identify and avoid or reduce carbon intensive materials. The waste management plan should be project specific and aims to minimize the generation of waste, thereby reducing CO2 emissions from transport and disposal. It also allows us to identify materials which can be recycled or reused. We're cognizant that recycling may actually increase CO2 of a material, such as paint or drywall. So it's always best to work with procurement teams on limiting the purchase of these materials as much as possible. For procurement of services and materials, sustainable policies are usually embedded into contractor selection and procurement processes in an effort to select providers with lower carbon impacts. This can be measured using local providers to reduce travel distances, use of ISO 14001 certified suppliers, and reviewing statements made in suppliers' corporate sustainability reports. Incorporation of quality management standards is also a part of it, with the requirement to select products and materials that are durable and resistant, which will withstand operational requirements and pressures, thereby minimizing efforts and energy for maintenance and repairs. For example, concrete can be a major contributor to carbon emissions. Options are available in the market for low carbon products, which consider alternative or recycled cementitious materials, locally sourced or recycled aggregates, and closed production systems that incorporate carbon capture. Construction teams will work closely with design teams to ensure that low carbon concrete is considered on the project without sacrificing specifications for safety, durability, and resilience. Sustainable procurement policies also help us with certification against mandated or client requirements such as LEED, CEQUAL, BREEAM, or in Canada, Envision certifications, which are becoming more commonplace in industry. And so having a procurement policy helps to ensure that low carbon materials are being supplied by vendors and we can achieve that certification. Finally, having a procurement policy is also an opportunity to raise awareness in the industry on rising expectations to reduce CO2 emissions in construction throughout the supply chain. So again, on soil reuse, the reuse of clean soil on the project or nearby projects as backfill for embankments, bridge abutments, drainage features, or soil caps, for example, is always optimal and can lead to immense CO2 savings. In Toronto, for example, each truckload of soil can be equivalent to 2 kilograms of CO2 per kilometer. On a 5-year linear project and up to 100 trucks per day, this could equate to millions of kilograms of CO2 from soil movement over the course of the project. This number could be higher or lower depending on where you're sending your excess soil to, but also where your imported soil is coming from. Soil disposed at landfill is always a last resort, mainly due to cost, but also because it can lead to reduced landfill capacity, which creates the need for more landfill space and further creating more greenhouse gas emissions. Hence, sending landfill must always be avoided if at all possible. In fact, here in Ontario, it will soon be illegal to send clean soil to landfill for that reason. Understanding the amount of clean, non-contaminated soil we have on site also lets us optimize reuse of excavated soil within the project limits and avoiding having to import backfill from other projects, which creates more emissions. Contaminated soil is identified through phase 1 and phase 2 environmental site assessment processes at detailed design, which allows us identification and characterization of the contaminants which are above regulatory limits, so that we can target in situ remediation efforts where required, as well as maximize soil reuse where possible. If the soil is contaminated, in situ remediation or on-site treatment and reuse of slightly impacted soil is preferred to keep CO2 emissions low from trucking to landfill and from exceeding landfill capacity. In the graphic, we also see trees. Trees are carbon sinks which can absorb up to 21 kilograms of CO2 per year. As such, they are critical to us in reaching our carbon reduction targets. Avoiding harm to trees and vegetation is always critical, but cannot always be achieved due to design constraints. Trees and vegetation that are adjacent to construction are always protected using fencing or exclusion zones, with strict monitoring and enforcement by project management on contractors who trespass. In Canada, where mature trees must be removed from a project footprint due to design constraints, they are typically replaced at a compensation ratio of 3:1, but can be as high as 8:1 depending on the environmental value, such as providing habitat for protected species or contributing to high biodiversity. High tree compensation ratios can also be embraced by the contract authority to offset a large proportion of construction-related CO2 emissions. Having this in the contract will ensure that these carbon offsets will be achieved. Construction vehicles and equipment are always on a construction site. These are one of the most visible environmental impacts on construction, and can be a large emitter as well. Best management practices are used to reduce CO2 emissions as much as possible, such as incorporating a no idling policy on site, regular maintenance of equipment to optimize engine performance and fuel consumption, selection of appropriately sized powered equipment to optimize energy consumption, such as the use of 5-ton versus a 20-ton excavator for smaller tasks. Also, selecting equipment can be powered by renewable or lower emission resources, such as electrical excavators are becoming common in the market. Those that are powered by LPG or other alternative fuels, such as biodiesel and propane. These can be coupled as well with other technologies, such as solar, for the use of low-powered equipment, such as monitoring stations and for signage. As I mentioned before, traffic management is also a consideration. It's very important that we consider traffic management on construction projects with regards to carbon reduction, because effective traffic management during construction can lead to reduced congestion. We basically want to avoid congestions, which will lead to more emissions. That's why projects will typically work closely with transit authorities on keeping as many lanes open as possible to maintain safety on the roadways, as well as to avoid congestion as much as possible. It is also important to consider to keep cyclist and pedestrian routes open and safe for use. Keeping the public safe is our top priority, and by contributing to keeping safe multimodal travel options available, we are helping to keep emissions low during construction. That's it for me. I hope you found that informative.
Thank you, Ryan. I think what I'd like to get across in the close of our discussion here is that it is incredibly important to be thinking in the round and working as an integrated team to get those carbon reductions in there early. And certainly I've been doing this kind of thing for a very long time, and that's where I've seen the best results. It's an iterative process with the designer working on optimization and the contractor also presenting innovative solutions, etc., and making sure that that is taken through to when you go through to construction. I can't say, I cannot stress how important it is to be integrated, not just from the design perspective and the contractor perspective, but with the project owner as well. And this is all in line with the publicly available standard 2080 that sets out nice and clearly the way to the guidance to manage carbon in infrastructure. And it's about engaging the whole of that value chain to get the best results in this low carbon world. So I'll pass across to you, Carole.
Thank you, Kim. Thank you, Yann. Thank you, Ryan. Very informative stuff. So now we're going on to the Q&A. We've got quite a few questions, so I'll start with, I'll try this one. What kind of carbon reduction goals or targets do construction projects set for themselves? So I'll just repeat it again. What kind of carbon reduction goals or targets do construction projects set for themselves? So I see construction. Ryan, I'll let you take that one.
Sure. Well, here in Canada, many of the transit authorities here will require us to set sustainability targets, which includes carbon reduction. I guess these could include something as simple as installation of energy-saving devices in our site offices, such as light sensors, timers, Energy Star rated PC, personal computers and appliances. And also maybe having a target for percentage of energy powered by renewable energy, such as solar panels. For more construction activities, we might look at things like sourcing of recycled aggregates or reused soil for backfill. We would also consider the need for steel products and look at alternatives such as wood materials for structure. And also powering of equipment using like alternative fuels, like I mentioned, like biodiesel, LPG, things like that.
Thank you, Ryan. Okay, another question.
Maybe I can add that in terms of design, we can make a cooperation between projects, for example, to keep a goal according to, for example, the carbon footprint per kilometer from different projects. It's a way to give goals, you know, one project to another.
Thank you. Okay, so another question. How do you influence other project members, such as suppliers and contractors, to adopt your carbon reduction strategies? How do you influence other project members, such as suppliers and contractors, to adopt your carbon reduction strategies? Ryan, you want to take a stab at that too? Sure. Picking on you.
That's not nice. Yeah, so influence, we influence our subs, like I mentioned earlier, by having sustainable procurement policies. I mean, that's the best top way to influence our requirements to all of our suppliers, because that really should get communicated down the chain through contract arrangements. It can be a powerful tool for communicating carbon reduction throughout the supply chain. If a client tells us we have to buy sustainable, then we have to react by telling our suppliers to provide us with sustainable products, and they have to tell their suppliers, and so on. So for large projects, we normally require that, or usually the client requires that a sustainability plan is prepared and communicated to all of our suppliers. That way they're not just getting a policy statement with like vague wording, but they're actually getting a clear 100-page plan on exactly what they need to do to achieve our requirements and influence them to reconsider their products to make sure that we're going to achieve our targets. Again, the plan would also be included in supplier contracts. So again, it's being communicated to suppliers, but it's also being enforced through contract measures. So we can usually check these things that they're happening through various audits, inspections, and whatnot.
Anybody else want to add in something?
Well, this is also about this is all about procurement. So we can give goals for the whole project and for any of the contractor or any of the supplier displayed on each kind of work. So it's all about putting these goals in the procurement.
Kim, do you want to add anything, or should I go to the next question?
I was just going to say, couldn't agree more with Yann in terms of procurement. The way everything is contracted really does have an influence again on these low carbon outcomes. Certainly, when I'm looking at projects, is one of my biggest replies is, it's not in the contract. Why should I be going for this low carbon material or whatever we happen to be looking at? So again, spot on. It really helps with the way the contract and the procurement is done, particularly through the supply chain down to tier 2 and tier 3.
Thank you. Go on to another question, if that's okay. How do you verify during construction whether these carbon strategies are being used? How do you verify during construction whether these carbon strategies are being used? Construction again.
Exciting topic.
I'll let you start. Go ahead, Ryan.
I can say that I know that many owners, especially in France, make a carbon footprint that at different steps during the design and during the construction as well, for at each step to monitor the carbon footprint of a project. So this is a way of fixing goals step by step and followed and monitored during either the design and the construction.
Yeah, I'll add to that. Verification comes through many forms that we do on our subs. We do daily inspections. We do usually internal audits as well. These are done by ourselves, but usually done by industry professionals as well. The auditing can also be done through one of the consortium partners, so Mott MacDonald, Setec, or Dragados might usually also send out their own staff as corporate bodies to conduct audits on the JV as well. So that's another form of verification. But also we're subject to many forms of external auditing as well. Regulatory agencies can audit us at any time, and if they audit us and they find something being done wrong by one of our subs, we immediately react by informing that sub and correcting the action. Independent bodies, usually in Canada, we're mostly always required to have an independent body come and audit us at least annually on our projects, and these are done through, traditionally these have been environmental audits, but more so they are becoming more and more sustainability related, including carbon reduction uses. And then of course we're always open to client audits as well, just to be transparent.
Okay, we'll continue. Kim, do you want to add something?
Not
Okay.
not on that one. I'm keen for the next one.
Okay. What sort of tools and techniques can you use at the design phase to reduce carbon? So I'll let you take that.
I was a bit too keen there, wasn't I?
No.
So, I mean, there are a plethora of tools and techniques out there, but certainly from my personal experience is that making sure that the tools are easy to be used for a non-carbon specialist, and you can use them within their within your own lifetime. I have literally spent most of my career playing about with very hard to use Excel spreadsheets that crash at regular intervals. But what's happening with software these days is it is much easier, and it's integrating with the BIM models that they're actually working on at the time to make those informed decisions. I think I mentioned very quickly earlier on about the Moata Carbon Portal again, which is all about making sure that it's used by designers, engineers to make those informed decisions nice and early in the design process. But I could literally spout lyrical for days on the various tools. I know all our competitors, there are at least 19 out there for the design phase.
Okay, thank you. Yann or Ryan, anything to add? Should we go to the next question?
No, thanks. I don't have anything.
Okay. Do you think we can achieve net zero with all construction projects? With all the construction projects that are taking place? Do you think we can achieve net zero with all the construction projects that are taking place? I think, Kim, who wants to have it? Your mind, someone's on mute.
Can I be very keen and leap in here? Because again,
yes,
it is my favourite subject, achieving net zero in particularly very complex infrastructure projects. So again, with what I'm seeing on the horizon, also with again in the UK with the Committee on Climate Change, they've set out a roadmap for actually bringing construction emissions from construction projects down. I think we've got to be net zero by 2045 in the UK. Also looking across the steel industry, the concrete industry, for example, they have all published very clear roadmaps, again in the UK, for achieving net zero by 2050. I think the only proviso for that, that is that certainly for the concrete and the steel industries, it's very heavily reliant on carbon capture storage. And again, that requires a lot of upfront investment in the first place, and they're looking for government to help push that forward. I'm always an optimist, and again, net zero is my thing. I think we can achieve it, and certainly the groundswell that I've seen over the past couple of years for everyone in our industry to be engaged in achieving low carbon net zero outcomes. I personally have never seen anything like it in my career, and again, I've been at this quite some time.
Thanks, Kim. I'll go on to the next question then. If Yann and Ryan have nothing to add. What impact will the UK's commitment to the COP26 have on how this all has been approached to this date? Will we all have to resharpen our pencils, or are we already now heading in the right direction? Who wants to go for that? Please. And you're on mute again, Kim.
Oh, I'm on mute again. So again, it's following on from what I was just talking about. Is yes, we all definitely have to resharpen our pencils, and certainly with COP26 happening in Glasgow in November, the spotlight is on the UK, and having worked on the global stage, I can say that the UK is in a very good position for this, again, with respect to infrastructure carbon and reducing from that perspective. I think there's still a lot of work to do. I think we are, yes, as I said before, COP26 in November is something that we're all aiming at in terms of our respective companies, but it's not just the COP26, it's way beyond that to achieve our net zero ambitions, not just in the UK, but globally. Hopefully that answered the question.
Thank you, Kim. Okay, Ryan and Yann, shall we go to the next? Nothing to add?
Yeah, nothing to add now.
Okay, I won't announce I won't announce the name of the people who've asked these questions. So the next question is, well, thank you for the presentation. Are you aware of any or other research on steel reinforcement replacement, such as basalt bars, which are said to be light, so easy to handle, and have a low carbon profile? Once we have optimized the design and site activities, steel appears to be the next area to concentrate. Any comments? Who's good on that one? I was thinking Ryan, but seems to.
I can leap in from a high level.
Thank you.
So again, across the industry, as you rightly pointed out, steel is one of the hard hitters in any infrastructure project, along with concrete. And there is a lot of research going on at the moment. I think one of the research areas is also looking at carbon fibre reinforcement. Again, I think all our respective companies are doing their research on this side. One of the, I suppose, key issues that we have is, although we're researching all these various new technologies and ways forward, is that actually our standards and our specifications have yet to catch up with it. So it can make it slightly harder to implement, I suppose, what you would term as exotic materials. I could wax lyrical for a very long time on that one, but I'll let my colleagues leap in from their perspective. But there is a lot of research going on, particularly in the steel and the concrete sectors at the moment.
Anyone want to add anything to that?
No.
Ryan, can you add anything?
No, I can't really comment much on steel, but concrete certainly, yeah. I mean, there's been a lot of developments in the concrete industry here in Canada. Like I mentioned, trying to optimize where we gather our aggregates and source materials from. But also, there's a lot of concrete providers out there providing low carbon solutions, such as I mentioned, carbon capture systems. So they're trying to contain all of their emissions in a closed loop system to try to reduce those emissions as much as they can, and reusing recycled materials as much as possible as well. So I don't think we're there yet, but we are getting there quite rapidly, and it's very exciting to see. And we always look at the innovative solutions to incorporate in our projects. They just have to be locally available, and yeah, that's.
Thank you, Ryan. Thank you, Kim. Next question. Have you experienced the use of disruptive carbon reduction measure in the recent past? For example, hydrogen excavators. And the person put a link in there, so I'm obviously not going to click on that. So I'll repeat the question. Have you experienced the use of a disruptive carbon reduction measure in the recent past? For example, hydrogen excavators.
I have been involved in the project in Quebec where they have mandated all equipment on site to be powered by biodiesel, which is a very interesting strategy. But I haven't seen any examples of hydrogen being used on our projects. So I would assume that's mostly due to being locally available, at least in Canada.
Thank you, Ryan.
I can say that I know that this has been tested in France, but it's only tests right now. It's not something very usual.
Thank you.
And I can concur with that. It's not the normal run of the mill, mainly
No.
because of the existing infrastructure to carry that out. I mean, I've seen fuel cells being used for instead of diesel generators, etc. But at the moment, it's not the low cost option. It is more expensive. And as Ryan said, there seems to be a what I'm seeing across the industry is that transition period using biofuels as the interim. But I certainly see hydrogen, again, the world is still out in terms of hydrogen versus electric. I would be expecting to see a sea change in that, certainly within the UK, for plant going forward.
Yeah, and don't forget that, as I told you previously, use of lime and concrete and steel is the main issue. It's not about really the kind of fuel used for the mass hole. It's more about well, the extra material that you put into the construction.
Okay, we just have a comment, and I'll just read it in case someone's missed it, and maybe if one of the speakers want to say anything about it. In a recent article in Wired, Bill Gates quoted as saying that addressing CF in steel, cement, aviation, and land use is a hard part, whereas the achievements in electric cars, solar, and wind power were only the easy part. Anyone have a remark?
No.
Apart from he's right, is we're delivering on the easier parts, as in greening the energy, etc., and that's all coming down. Certainly, construction in carbon in infrastructure is one of the hardest ones. I mean, that's certainly why I love working in this, because it's really hard to do, but achievable.
Ryan, did you want to add something?
No, that's fine.
Okay. Next one, lovely presentation to Yann. Regarding the good tools out there, is there any particular database that can be used to calculate carbon emissions that you would recommend?
Is that for me? Or
I guess so, yeah. Well,
maybe,
go ahead, you can answer, we'll let everyone answer.
Well, maybe Kim can answer with the database used in the UK.
Okay. So in terms of databases in the UK, there's quite a few out there, but in a recent publication we showed that certainly within the infrastructure sector, that we're struggling with being able to compare, I suppose, apples with oranges. But certainly again within the UK, we all refer back to the ICE database for embodied carbon for general carbon emissions, and then we'll be looking at environmental product declarations as well to calculate our carbon footprints. But in terms of an overarching database, there's an awful lot out there, but there is no overarching database at this moment in time, but there is a call to address that very quickly.
Mm-hmm.
I just want to mention the slide that I showed earlier comes from a database from the US EPA. The numbers are US centric, I guess, but it does offer very useful tools on calculating carbon from materials, and it allows you to see the options of how much carbon savings would you have if you recycled or sent to land versus if you sent to landfill. But also for organic materials as well, if you were to reuse vegetation and things like that. So I recommend doing a quick Google search for the US EPA WARM tool. I can't remember what the acronym stands for, but very useful to calculate carbon reductions for very basic materials in the household and on construction projects as well.
Yeah, I think we have the basics in the UK, so that's referring back to bays, etc. But in terms of the nuts and bolts of infrastructure, again, I suppose the devil's in the detail. There's still a bit of a way to go.
Thank you. Hello, Ryan. You're stating that contractors are preferring the use of intra-project materials instead of importing materials from other projects. To what extent? Is COT emission always taken into account, as there is probably a max distance where it is economically uninteresting to transfer materials, even if a section has too much of it? So that's for you, Ryan. Do you want me to repeat the question?
No,
No?
Yeah.
Okay.
Not always, no. I mean, this is an industry changing for the better, I hope. It really depends on what's written in the contract, to be realistic about it. If the client is asking for carbon reduction targets, we will certainly look at materials which have the highest yield for carbon savings as well. So this is just one tool that I showed to show where those savings can be made. Now it's going to be different for every project. Like the user has said, it depends on how far the materials are coming from. So those targets may not be what's written. So every project is going to be very site specific, and it usually requires the use of a carbon expert to be able to truly calculate those numbers without using the generic numbers from the US EPA warm tool that I did. But certainly it needs to be driven from the top down, because if the industry does have a lot of changes to make, and carbon reduction must be one of them. But the best way to drive that forward is from the owner side, to put that into contracts, state that you need to reduce your carbon, and the contractor will find those opportunities to reduce using the best strategies available to them and for that location.
Thanks, Ryan. Kim or Yann, do you want to add anything?
No.
Okay, I'm conscious of time, so we'll just, sorry for the questions that we couldn't get to, but I'll ask one more, and then we'll go into the closing. The cost of low carbon materials, how does it compare to the cost of conventional ones?
Yes, in France, I can say that for cement, this has been a kind of a comparison, and that gives the answer of this comparison is that you can the extract cost is not so big. So this is quite an issue to look for low carbon cement. So this is a good question. This has to be known, especially for example, drainage system. We can test and use quite massively low carbon cement and low carbon concrete. So yes, this is an issue, and this is not low carbon cements are not so expensive, and has to be, and where they have to be used as stream.
Thank you, Yann. Ryan or Kim, can you add anything?
Sorry.
It depends on the project, of course, and where you're located, like I mentioned earlier. But yeah, they can be more expensive, low carbon materials. But like I said, the industry is improving. It's getting there, and I truly believe it will become cheaper or the same price, actually, as more suppliers adopt those approaches.
Yes,
and it becomes more common in the marketplace.
Yes, but we just have to precise that the test which has been done in France take into account that at the end of the day, labor force is the more expensive cost of a structure. So at the end of the day, low carbon cement, for example, can be a bit more expensive, but at the end of it, it is not so in comparison, it's not so expensive to at the end of the day for a structure, especially for small concrete use, for example, in drainage.
Okay, thank you. Okay, well, conscious of time, everybody, thank you so much for joining us and spending the last hour with us together on this forum. I just want to ask each of our experts, who are obviously very passionate about this subject, if you can just give one word to our audience, what would it be? And I'll start with Yann. What's one word that you would give if you would give?
Well, yes, one keyword would be modeling, because you've got many good or bad choices to do. So modeling is the only way to have an answer in terms of design.
Okay, Kim, what would your one word be?
Positive. I think we're all heading in the right direction. Still a lot of work to do, but we're heading in the right direction.
Ryan, you're always last but not least.
Influence. Let's keep influencing each other, influence our clients, influence our suppliers, and let's drive this carbon reduction effort.
Okay, thank you, Kim Yates, Yann LE GALLIC, and Ryan Rafferty. And everybody, again, thank you for spending the last hour with us, and we hope to see you again on one of these forums. Bye.
Bye-bye. Thank you.